Good morning, student. Today we are talking about the Woodward Fieser rule for dienes. See, Woodward and Fieser they have developed the rule to calculate the lambda max by which is we already calculated from the UV visible spectroscopy. So what that rule says, that rule is nothing but he has given the one formula for calculation of the dienes, and that formula is nothing but the first you take the base value, then effect of substituent, or we can say as contributors, and plus some other contributors. That formula is used to calculate the lambda max. So you can see the different types of dienes, that is acyclic dienes. It means there are two double bonds are present which are conjugated to each other. This is one double bond, then single bond, and then again double bond. So it is called as a diene, but this is the acyclic diene. So these dienes are trans to each other, that's why it's called as transoid. And if these two dienes are cis to each other, they are called as the cisoids. See, both are the cis position. So for this acyclic diene, we have to use the formula for the calculation is the same. You have to take the base value for this is the 270 nanometer is the base value, and then you can add the other contributors into it. These are the examples of this acyclic diene. This is a cyclic compound, but there is double bond present outside the ring. So this is also a cyclic diene because both double bonds are conjugated, but they are present in the both ring as well as the open. So rule for the cyclic diene for our syllabus, we have the homoannular diene and heteroannular diene. So what is the meaning of the homoannular diene? It means both the conjugated double bonds, if they present in the same ring, they are called as the homoannular diene. Okay, that's called as maybe the cisoid or transoid, but they are called as the homoannular diene, and generally then cisoid configuration you can see this. So this is an example. These are the two double bonds. This is B, if we label as ring A, and this is ring B. So this is we called as in A ring there are two double bonds are present, and these are the others. What we can say, these are the alkyl substituents, or we can say the ring contributors. They are present. So these are called as the ring contributors. And base value for this homoannular diene is always is 253 nanometer. Now we go to the heteroannular diene. In the case of the heteroannular diene, the two double bonds they are present in different ring. Okay, they are not in the same ring, and that is reason we can say the transoid system you can be observed with the help of this. And generally this value is 214 nanometer. You can see this is ring A, and this is suppose ring B. So the two double bonds they are present. This is one double bond here, then single bond, then double bond, and therefore it is called as the heteroannular diene. And this is one alkyl substituent, this is another alkyl substituent, and this is the third alkyl substituent. And also there is an exocyclic double bond that are we called as the contributors we can see. Now you can see the endocyclic double bond and heterocyclic double bond. Endocyclic means double bond is present inside the ring, and exocyclic means the rings are the double bonds are present outside the ring. These are the examples of exocyclic double bond, and for that exocyclic double bond you have to add 5. Okay, for this A ring this is exocyclic double bond. For this A ring, this is the exocyclic double bond, and for this B ring, this is the exocyclic double bond. So there are two exocyclic double bonds are here. For this A ring, there are two exocyclic double bonds are present. So we have to add bonds. So we are understanding here how the exocyclic double bond is there. Now you can see this A ring, there is one exocyclic double bond. For B, this is the exocyclic double bond. And for B ring, is there any exocyclic? No, this is only one. But for C ring, there is one exocyclic double bond is present here. And there's both this A and B, there is an exocyclic double bond, but this is not a diene. So the empirical rules for the diene, already you know, for the homoannular diene, there is a 250 base value is 253 nanometer. and for heteroannular diene it is a 214 nanometer. And then there is an increment for the alkyl substituent. If there is a one alkyl substituent is present, you add 5 nanometer. If there is an extended conjugation, then there you have to add the 30 nanometer. Okay, 30 nanometer because of the extended conjugation. And if there is an exocyclic double bond is present, then you have to add the 5 nanometer. So these are the increment. And if there are other substituents like polar substituents are present, like if there is alkoxy group, then you have to add 6. And if there is a halogens are present, then you have to add 5. And then it is for the other substituents also. Now you can see this is one example. We can take it here. Here it is a diene, but here it is a acyclic diene. So the base value we must take for this one is the 217 nanometer. And then you can go for the alkyl substituent. This is one alkyl substituent. This is another alkyl substituent. Alkyl substituent means the alkyl group or carbon atom which is directly joined to this carbon-carbon double bond. So this is 1, this is 2, this is 3, and there is no other alkyl substitute here. So there are 3 alkyl substitutes. You have to add this value and you can calculate the lambda max. So for this, then you can take the base value for this diene and you can calculate. So the 214 is the base value for this, and then you can add, there are 3 alkyl substituent, and if you make the sum of this all, it comes to the 230. Okay, so this is the calculated value, and the practical value is also coming the 234. We are not having the practical or observed value, but we can calculate. So other substituents are here 0, so that we can see it here. Another example you can take it. This is the homoannular diene. Is this exact the example? And you can see in this example, these double bonds are present, and we can label this alkyl substituent. So the base value is for homoannular diene is 253 nanometer. Then you have to add alkyl substituent. This is one alkyl substituent, this is another alkyl substituent, this is third alkyl substituent. So there are 3. So 3 into 5, 15. 15 plus 2, 53. So you will get the value for this is 253 plus 15, and then calculated value is coming to 268 nanometer because other effects are 0 here. So in this way, you can calculate. I can take this another example for like this. Now you can look at here. Here is a double bond and single bond, double bond. Again, single bond, double bond. It's a kind of example of a triene. So we can consider here this one is an extended double bond. Okay. So the value, it's a heteroannular line. So base value for heteroannular line is the 214 nanometer. Now you can go for the alkyl substituent. I will just label it alkyl substituent here. Here is 1, here is 2, here is 3, here is 4, and here is 5. So there are 5 alkyl substituents are there. So 5 into 5, there is 25. Okay, and then if I considered the diene system, suppose this is my diene, and there is one more extra double bonds are there in conjugation, and this double bond I can consider as the extended conjugation, and this is the extended conjugation. So I have to add 30 again. So this is here 30, then 25, then other effect. Is there any exocyclic double bonds are present? Yes, there is exocyclic, because if I label this ring as A, then this ring as B, and this ring as C. So you can see if I hide this A ring, there is no exocyclic double bond. But if I hide this B, then you will find one double bond here and the double bond. So there are 2 exocyclic double bond for ring B. And if you see this ring is D, again you hide this ring, there is one exocyclic. So there are 3 exocyclic double bonds are present, and for each exocyclic double bond you have to add 5. So it comes to the 15, and add this value together, you will get value is 234. So in this way, you can calculate the lambda max value. So important note is that if there is an homocyclic and heterocyclic, both the systems are present in the same molecule, then you must consider for the calculation of lambda max, the base value is homoannular diene, that is 253. Here is an example. Now you can look at here. There are two different rings are present here. Suppose if I label this is ring A, this is ring B, and this is ring C. Now you see in the ring ABC, so there is a heteroannular, and again in B there is a homoannular. So which one is considered? So as the rule says, you can consider homoannular. So base value should be 254. That we have to write it. Then there are other substituents are present that we have to mark it. Once you understand that base value, then you go for the alkyl substituent. This is the one group which is not there in our syllabus, but there is no significance role in that contribution, so there is nothing. So we'll take alkyl substituent 1, this is alkyl substituent 2, this is alkyl substituent 3, this is alkyl substituent 4, and this is alkyl substituent 5. So there are 5 alkyl substituents are present. So we can take for each alkyl substituent there is a 5 value, and then you have to go for the next is the exocyclic double bond. Okay, so I can just write here ki 5 alkyl substituent, so I can take that 25 value, है and then other thing exocyclic double bond, you can see for this ring A there is one exocyclic double bond, for B there is one exocyclic double bond, so 2, for C there is exocyclic double bond, yes. So there are 3 exocyclic double bonds are present, and for each exocyclic double bond you have to add the 5, and in this way, and there is an extended conjugation also is there. You can consider, suppose this is a diene, so there are 2 extended conjugations are present, that you have to add again 60, 30 plus 30. So here is the result. You can see it here, the value which is coming after the calculation is the 253, then there is a alkyl substituent 25, then 60. You add together, you will get the value, and that value is nothing but the lambda max. So several other examples are again there to calculate the lambda max value. Again, here it's a homoannular diene, so the value 253. Then you can find out the alkyl substituent. See, this is one alkyl substituent, this is another alkyl substituent, this is third alkyl substituent, and this is the fourth. So fourth, and is there any other alkyl substituents are present? That also you have to calculate it for this molecule. Um, so 1, 2, 3, and 4. There are 4 alkyl substituents are there, and that is we call as the rings residue. And is there any exocyclic double bond? There is no exocyclic double bond in it. So the value, you have to add these 3 values, and you will get the exact number.